Okay, my dear children, see these points. The next point is invertible function. What is meant by invertible function? Yesterday, just I have introduced that point in invertible function. Good afternoon, my dear Joseph. How are you?
Fine, sir. Good afternoon, sir.
Good afternoon. Have you watched the video, yesterday video?
Yes, sir.
Okay, any doubts?
No, sir.
Okay. Are you artificial intelligence? Have you opted?
No, sir. Computer science.
Okay. Okay. Just let us recall the previous knowledge. The previous class we have discussed composite function of two functions. F and G are two functions. If F and G are two functions, how do you denote the composite function of these two functions? F is a mapping from A to B. F is a mapping from A to B. Listen carefully, my dear children. I'm not writing on the screen. Listen carefully. Pay attention here. F is a mapping from A to B. G is a function. Another function. G is a mapping from B to C. Then what is the composite function of these two functions, F and G? Okay, tell me, Grayson.
Sir, G circle F, sir.
Okay, very good. G circle F is called composite function of functions F and G. Then what is the domain of G circle F? What is the domain of G circle F? Grayson, can you tell me? What is the domain of G circle F?
A, sir.
What is the codomain of G circle F?
C, sir.
Very good, very good. Good afternoon, my dear Ashwant Ram. How are you?
Good afternoon, sir. I'm fine, sir.
Okay. Have you watched yesterday video?
I did, sir.
Watched it or not?
I did watch, sir.
Watch it. Watch it. Do you opted artificial intelligence?
No, sir.
Computer science.
Yes, sir.
Okay. Now, come to the next point. Invertible function. Okay, one more time. How do you define? Good afternoon, my dear Preetika.
Good afternoon, sir.
How are you?
I'm fine, sir. How are you, sir?
I'm also fine. Thank you, my dear Preetika. Have you watched yesterday video?
Yes, sir.
Completely, not only just 5 minutes or 10 minutes. You should watch the video completely.
Yes, sir.
Okay, my dear children. Not for 5 minutes or not for 10 minutes. You should watch the video completely. Okay. Have you opted
Okay,
artificial intelligence, Preetika?
Sir?
Have you opted artificial intelligence?
No, sir.
Computer science?
No, sir.
Which subjects you opted?
Sir, PCMB, sir. Biomax.
Okay, 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 okay. Good afternoon, my dear Kiran Raj. Good afternoon, my dear Kiran Raj. Kiran Raj. Kiran Raj. Yes, good afternoon. How are you? Have you watched yesterday video? Have you watched yesterday video completely? I'm fine. Thank you, Kiran Raj. Thank you, my dear Kiran Raj. Have you watched yesterday video completely? Why? Why didn't you watch? Don't you have time? Don't you have any time for watching the video? Kiran Raj? Don't you have any time? Have you written classwork notes, at least yesterday classwork notes? Okay. Now come to the point, next point, invertible function. What is meant by invertible function? In the previous classes, I have introduced invertible function. All bijective functions are invertible. Simply to say, all bijective functions are invertible functions. Now let us take the definition. What is the definition of invertible function? A function f is a mapping from A to B
Excuse me,
is defined to be invertible
Sir,
if there exists. What, my dear Grayson?
sir, you have written inverse of a function, sir, as a topic.
Inverse of a function. Inverse of a function. Today's topic is inverse of a function. We are going to discuss what is meant by inverse of a function. If a function
Okay, sir.
if a function have inverse, then the function is said to be invertible function. If a function has inverse, then the function is said to be invertible function. What is meant by invertible function? What is meant by invertible function? It has inverse. Remember this point, my children. Invertible function means it has inverse. If a function has inverse, then the function is said to be invertible function. Vice versa. Okay. Now come to this definition. A function f is a mapping from A to B is defined to be invertible. It is said to be invertible if there exists a function g is a mapping from B to A such that G circle f is equal to IA and f circle G is equal to IB. If there is another function g, it should be defined from B to A, and that function should satisfy these two conditions. Then f is said to be invertible. The function g is called inverse of f and is denoted by f inverse. That is g is equal to f inverse. This is only definition of inverse of a function, or this is a definition of a invertible function. Okay, my children. But simply to say every bijective function is invertible. Remember this point. Remember this point. Every bijective function is invertible. Conversely, every invertible function is a bijective. Okay. See the second point that only I mentioned here. I mentioned that point here clearly. A function f is a mapping from A to B is invertible if and only if. Do you know how to read this one? IFF. Do you know how to read this
Yes,
symbol?
sir.
If and only if. IFF. IWF. It is read as if and only if. Or sometimes symbolically we can use by implies. We can use by implies like this. F is mapping from A to B is invertible. By implies f is a bijective function. If f is a bijective function, then we can say that it is invertible function. If f is an invertible function, automatically we can say that f is a bijective function. Okay, my dear children, is this point
Yes,
clear?
sir.
Yes, sir.
This point I have already told in the earlier class, previous class. Now come to the property of composition of functions. If f is a mapping from x to y and g is a mapping from y to z and h is another mapping, another function, h is a mapping from z to s, or three functions, then h circle of g circle f is equal to h circle g circle f. This is nothing but associative property. Do you remember this property? Associative property means we have to take three numbers. In the number system, you have already studied associative property. Whereas in this case, we have to take three functions. Here, we are taking three functions, namely f, g, and h. Three functions f, g, and h. And we have taken the composition of these three functions. H circle, g circle f is equal to h circle g circle f. This property is called associative property of composition of functions. Okay, my children. Right. Now come to the next point.
Yes, sir.
This point is a combination of composition of two functions and inverse concept and composition of functions. See here, let f is a mapping from x to y and g is a mapping from y to z to invertible functions. These two are invertible. What is meant by invertible functions? Tell me. F is invertible function. What is meant by invertible function?
Sir, it's bijective.
Joseph?
Bijective, sir. F is an inverse function.
Yes, f has inverse. F is invertible function means f has inverse. Okay, my children, remember this point. G is also invertible function. What does it mean? What does it mean?
G has inverse, sir.
Yes, G has inverse. G is also invertible function means G has inverse. F is also invertible function means F has inverse. G is invertible function means G has inverse. Then G circle F is also invertible with G circle F whole inverse is equal to F inverse circle G inverse. F inverse circle G inverse. This is a property on the concepts, the combination of the concepts, composition of functions and inverse of a function. Composition of function and inverse of a function. By combining these two concepts, this new statement was derived. Okay, my children, just remember this one. Just remember in the questions, in the exercise, just they will give the functions. They have to find their composition function and their inverse. Now come to this point. How to find inverse of a function? Suppose f is mapping from A to B. F is a mapping from A to B. And we are showing this function f in the arrow diagram like this. Like this, I have taken the elements of set A and elements of set B. Just I am connecting this element 1 to A, to X, 3B, 4Y, 5Z, 6C. By observing this arrow diagram, which type of function this one? Which type of this function? Which type of this function?
Onto function, sir.
Only onto? Is it not one function, Preetika?
No, sir.
It is not one function.
Sir, it is also one function, sir.
Please observe carefully, Preetika.
Sorry,
It is
sir.
one function and also onto function. Indirectly, it is a bijective function. Now, this is arrow diagram. I represented this function f from A to B in the pictorial representation. Now, f is, how do you write this function as a set of ordered pairs? Can you tell me, Blessina? Blessina,
Yes, sir.
can you tell me this function as a set of ordered pairs?
So 1 comma A, sir.
1 comma A.
A, sir.
1 comma A.
2 comma X, sir.
2 comma X.
3 comma B, sir.
3 comma B. Very good.
4 comma Y, sir.
4 comma Y.
5 comma Z, sir.
5 comma Z.
6 comma C, sir.
6 comma C. Very good. Very good. Now, is it a bijective function or not? Blessina?
It is an bijective function, sir.
Why it is a bijective function?
So because all the elements in codomain has an image in pre-image in domain, sir.
What is that condition? What for that condition? If every element in the codomain has pre-image, then what do you say?
Has pre-image in
Which type of-
domain, sir.
Then which type of function we say that
Onto
function?
function, sir. Bijective
Yes.
function, sir.
Onto function. Not bijective, onto. One means
Yes, sir. Onto function.
what is meant by one? Can you tell me what is meant by one function? Do you remember the definition of one function? Definition of one function. Definition of one function. Sten Jensen, can you tell me? Definition of one function. Definition of one function. Okay, Jerome Jasliraj, can you tell me?
Yes, sir. So distinct
Tell me
elements are distinct images.
Yes, distinct elements of domain should have distinct images under the given function. Remember this definition, my dear Blessina. Blessina.
Okay, sir.
Hello, sir. Hello. Yes. Tell me, my dear children. Yes, tell me. Is it a bijective function or not?
Sir, it's bijective, sir.
Yes, sir.
Yes, it is a bijective. Sorry for the interruption. I got a phone call, that is why internet connection disconnected. So it is a bijective function. Now let us write its inverse. F inverse. F is a mapping from A to B, then F inverse is a mapping from B to A. Codomain become as a domain and the domain become as codomain. Now we write X, Y, Z, A, B, C, 1, 2, 3, 4, 5, 6. Okay, my children. Just in the reverse process, what is the preimage of X here? What is the preimage of X?
2, sir.
2, sir.
So we have to connect 2, just in the reverse order. What is the preimage of Y?
4, sir.
So we connect to Y with 4. What is the preimage of Z?
5, sir.
So we connect Z with 5. What is the preimage of A?
1, sir.
1. So we connect A with the element 1. What is the preimage of B?
3, sir.
3. What is the preimage of C?
6, sir.
6. Just in the reverse order, just a mirror image, just like a mirror image. Then F inverse, just suppose a function is given like this in the form of set of ordered pairs, then F inverse can be found easily, just reverse the ordered pairs, that's all. So A comma 1, here 1 comma A is there, 1 comma A. Are you watching the screen, my dear children? Are you watching the? Yes. Here
Yes,
ordered pair 1 comma A, we can write it in a reverse order. Then tell me the remaining ordered pairs. Yashwantram.
Sir,
Tell me the remaining ordered pairs in the F inverse. Remaining ordered pairs in the F inverse. I wrote here.
sir,
First ordered pair.
ordered pair B, 3.
Ordered pair
B, 3, sir.
B, 3.
C, 6.
C, 6. That's all. Yashwantram.
X, 2.
X, 2. Very good.
Y, 4. Z, 5.
Y, 4. Z, 5. This is nothing but F inverse. Sometimes they will give the function in the set of ordered pairs. Then it is easy to find its inverse. Understood this step, my children, how to write inverse of a given function if a function is given as set of ordered pairs.
Yes, sir.
Understood this point, my children? Right. There is another method. To find F inverse. This is one method. If function is given as set of ordered pairs, then we can easily find out its inverse. And sometimes they will define as a function. Suppose F is a mapping from F is a mapping from R to R. F is a mapping from R to R, defined by f of x is equal to like this. If f is a mapping from R to R, defined by f of x is equal to 5x plus 3, then find f inverse. If you observe here, this function is not defined as a set of ordered pairs. Yes or no? As in the previous example here, f is defined as a set of ordered pairs here. In this case, we found its inverse easily just by writing the reverse ordered pairs. But in this case, in this example, if you observe, the function is not defined as a set of ordered pairs. Yes or no? In this case, if you want to find inverse of a given function, follow these steps. Step 1. Let y is equal to, as you follow to check or to prove the given function is onto function. First step, y is equal to f of x, or f of x is equal to y. Okay, or f of x is equal to y. F of x is equal to y. Step 2. In LHS, if you observe, f of x is there. What is the value of f of x here? What is the value of f of x here?
So 5x plus 3.
Substitute this value in LHS. Substitute this value in plus 3 is equal to y, because f of x is equal to 5x plus 3. F of x is equal to 5x plus 3. This is the second step. Remember these steps, my children. First step, we take f of x is equal to y. Directly we can take this one. We can take this step directly. Second step, in this LHS, f of x is there. We have to substitute f of x value. F of x is equal to y, because f of x is equal to 5x plus 3. Now step 3. From this equation, we have to find the value of x. In terms of y. From this equation, we have to find the value of x in terms of y. How do you find it? Tell me. Can you tell me? Can you find the value of x from this equation, my dear children?
Sir, x is equal to y minus 3 by 5, sir.
Yes. X is equal to, tell me step by step. Tell me, Grayson, step by step.
Sir, 5x is equal to y minus 3, sir.
Yes. 5x is equal, first we transpose constant term into RHS, y minus 3. All of
And then x, yes, sir.
This implies
X is equal to y minus 3 by 5, sir.
y minus 3 by 5. Similarly here, you can write x is equal to f inverse of y. F of x is equal to y. F of x is equal to y by implies x is equal to f inverse of y. In the same line, the same line. Or you can take this one, f inverse of y. F inverse of y is equal to x. F inverse of y is equal to x. Okay, my dear children. So this number, as we have checked after finding the value of x, we had to check whether this number lies in the codomain or not. Okay. In rough notes, rough part, in the rough work. In the rough work, we had to check if y belongs to R. Yes or no? Y means codomain. If y belongs to R, that means in the codomain, it is a real number. Y belongs to R means y is a real number. This symbol means y is a real number. Then y minus 3 by 5 is also a real number or not? If y minus 3 by 5 is a real number or not? It is also a real number. Y minus 3 by 5 is also a real number. This real number lies in the means this number x lies in the domain, x lies in the domain, y lies in the codomain. Okay, so here what is meant by x here? F inverse of y. F inverse of y, we are writing this result, x is equal to f inverse of y. We are writing the x value, that is f inverse of y is equal to y minus 3 by 5, because x is equal to f inverse of y. This implies in the place of y, just write x. This implies f inverse of x is equal to x minus 3 by 5. In this line, in this equation, just to replace y by x. This is f inverse of x. Okay, my children. These are the steps to be followed to find inverse of a given function. First step, we have to assume that y is equal to f of x. This implies, by implies, keep here by implies, x is equal to f inverse of y. Otherwise, you can take like this also, f of x is equal to y. By implies, f inverse of y is equal to x. From this equation, we have to find the value of x in terms of y. Here we found the value of x in terms of y. After finding the value of x in terms of y, we have to check this number lies in the domain or not. Because x values lies in the domain, y values always lies in the codomain. Remember this point. X values lies in the domain and y values always lies in the codomain. So we have to check this number. This number is nothing but x. So this number lies in the domain or not. In the rough work, we have to check that if y belongs to R, means we are taking the y from the codomain. What is codomain here? Set of real numbers. So we have taken y belongs to R, means it is a real number. If y is a real number, then y minus 3 by 5, this number, the entire number is also a real number. So this is nothing but x. X is a real number. It lies in the domain. X is a real number. It lies in the domain. Therefore, we write here x is equal to f inverse of y. We have written like this. So we write that value here. F inverse of y is equal to, we write RHS as it is y minus 3 by 5. After this step, nothing to worry. Just to replace y by x. Here f inverse of y is there. Just to write f inverse of x is equal to, in the numerator y minus 3 is there. Just to write x minus 3 by 5. Remaining letters, remaining symbols, remaining numerical values we write as it is. Just we replace y by x. Okay, my children. So suppose x is a number. Then its image, what is its image under the function f? Can you tell me? Regarding this function f, if x is an element in the domain, what is its image? Can you tell me?
So 5x plus 3.
Very good. 5x plus 3. 5x plus 3. Okay. In the reverse order, f inverse. Suppose x is there in the domain of f inverse. Then what is its image? What is its image?
So x minus 3 by 5.
Yes. See here, x minus 3 by 5. Okay, my children. Here, x image is 5x plus 3 according to this function defined. We found f inverse of x means image of x under this function f inverse is x minus 3 by 5. This is also a real number. It lies in the real number. These are the steps. These 3 steps are very important. Questions may differ. Questions may differ. Questions may vary. But you should remember these 3 steps. First step, write this line. Write this line. F of x is equal to y by implies f inverse of y is equal to x. And the second step, I am repeating these steps, my children. In the place of f of x, we write f of x value in LHS is equal to y. We write the letter y as it is. In the next third step, we solve this equation. We solve this equation for x. It means solving this equation for x means we are writing the value of x in terms of y. Okay. We found here after finding the value of x in terms of y, we had to check in the rough work. We had to check this number is an element in the domain or not. What is the domain here? Real numbers. So we had to check whether this number is a real number or not. Okay. In rough work, we had to do that part. So if y is a real number, y minus 3 by 5 is also a real number. This number lies in the domain. So f inverse of y, x means here f inverse of y. So f inverse of y is equal to y minus 3 by 5 because x is equal to f inverse of y. This implies after this step, last step, just to replace y, replace the letter y. Remaining part as it is, just to copy and paste, except y. In the place of y, just write x. So f inverse of x is equal to y minus 3 by 5 is there. So x minus 3 by 5. That's all. These are the steps to be followed to find the inverse of a given function. If you recollect the steps, these steps we followed these steps only in verifying the given function is onto function or not. There's the same steps here also we are following the same steps. If you remember that steps to check the given function is onto function or not, we followed these steps again, same steps. Nothing else. Okay, my children. This is a second type of questions. This is the first type of questions. Functions will be given in the set of ordered pairs. In this case, it is easy to find inverse of the given function. Whereas in this case, we have to follow these steps. Understood this procedure, my dear? Blessina? Stains Johnson?
Yes,
Kevin Paul?
Yes, sir.
Joseph?
Yes, sir.
Yashwant Ram?
Yes, sir.
Preetika, Kiranraj,
Yes, sir.
Siraj. Yes. One more time, watch this video again. Okay, my dear children. Now come to these are only the concepts for this exercise 1.3. These are only the concepts to the exercise 1.3. Shall we start exercise 1.3 sums? Shall we start exercise 1.3 sums
Yes, sir.
now? Right. Now I will present a video, recorded video. I will present a recorded video now. Okay, my dear children.
Hello, my dear.
Okay, children. Hello, my dear children. Are you ready to listen the class? Are you perfect in the definitions of functions? Okay. Yes, yes. Stan Johnson, just wait for a moment. Wait for a moment. Okay. Open the textbook, my dear children. Open the textbook. Take the first question. Take the first question. Take the first question.
Yes, sir.
What is the first question? Just I'm arranging that photo mobile. What is the first question? Read the first question. Read the first question.
Sir, can I, sir?
Yes, yes. What is the first question?
Sir, let F is a mapping from ordered from 1, 3, 4 to 1, 2, 5, and G is a mapping from 1, 2, 5 to 1, 3 be given by F is equal to ordered pair 1, 2, ordered pair 3, 5, and ordered pair 4, 1, and
Yes.
G is equal to ordered pair 1, 3, ordered pair 2, 3, ordered pair 5, 1. Write down GOF, sir. G circle F.
Yes. Can you write this GOF? GOF. Can you write this one? See the first question. Page number 18. See question number 1. Given F is a mapping from, what is the domain here? Can you tell me? What is the domain of F?
Sir, 1, 3, 4, sir.
1, 3, 4. 2. What is the codomain?
1,
Sir, 1, 2, 5, sir.
What is the second function? What is the second function here?
G, sir.
G. What is the domain of this function? See here, F is defined as ordered pairs 1, 2, 1, 2, 3, 5, 4, 1. And G is defined as ordered pair 1, 3, 2, 3, 5, 1. Now we have to find G circle F. G circle F. Okay, my children. G circle F means what should we find? Take the first function. What should be the first function here?
F, sir.
Yes, F. I am representing this function F as arrow diagram. What are the elements in the domain of F? 1, 3, 4. What are the codomain of F? 1, 2, 5. What are the domain of G? 1 to 5. We have already written for the function G, 1 to 5 are domain. How do you draw arrows? See here, function F, 1, 2. 1 is connected with 2. 1 is connected with 2. 1 is associated with 2. 3, 5, ordered pair 3, 5. 3 is connected with 5. 4, 1. 4 is connected with 1. Understood this arrow diagram for function F?
Yes, sir.
Yes, sir.
Now come to the function G. 1 is connected with 3. 1 is see this arrow diagram, my dear children. Now tell me. G circle F. How do you write the ordered pairs? Can you tell me? 1, 2. 1 is connected with 2 and 2 is connected with 3. What is the ordered pair? 1 is connected with, yes, 1, 3. Very good, Blessina. Next, 3 is connected with 5 and 5 is connected with 1. What is the ordered pair?
3, 1, sir.
3, 1. Very good, Blessina. Next element 4. 4 is connected with 1 and 1 is connected with 3.
4, 3.
4, 3, sir.
4, 3. That's all. This is a composite function of F and G. Understood this point, my dear children?
Yes, sir.
Otherwise you can, without drawing this arrow diagram, without taking this arrow diagram, just from this also we can write this G circle F. See here, see 1, 2, 2, 3 in link ordered pair, just like link ordered pair. Do you remember transitive relation, my dear children? Transitive relation. Do you remember that? Just like transitive relation, we have to take one ordered pair from the function F and second ordered pair from the second function, which is linked with this ordered pair. So here 1 comma 2. What is the link ordered pair here in the function G?
2, 3, sir.
Then what is the resultant ordered pair?
1, 3, sir.
That's all. 1 comma 2, 2 comma 3. So resultant ordered pair is 1 comma 3. Similarly, take this first order, second ordered pair, 3 comma 5. What is the link ordered pair in the function G? What is the link ordered pair? 3 comma 5. Here
5, 1, sir.
5 comma 1 link ordered pair. Just to recollect that knowledge of transitive relation, you have to take first ordered pair from the first function and the link ordered pair from the second function. Then we have to find the resultant ordered pair. We have to write that third ordered pair in the G circle F. Similarly, 4 comma 5. What is the link ordered pair here? 1 comma 3. Yes or no? For
Yes,
this
sir.
ordered pair 4 comma 1, 1 comma 3 is a link ordered pair, connected ordered pair. So 4 comma 3, we wrote this one. Without drawing this arrow diagram, directly we can write G circle F. Understood this point, my dear children?
Yes, sir.
Right. Now come to the second question. Question number 2. Question number 2. What, my dear Kiran Raj? What, my dear Stan Johnson? Do you have next class? My dear children, do you have next class? Which class, Kiran?
Sir, artificial intelligence.
You opted artificial intelligence. Kiran Raj. You have opted artificial intelligence. Kiran Raj.
Sir?
Do you have that class?
Yes, sir.
You have opted that subject. Have you opted that subject? Kiran Raj.
Sir, yes, sir.
Anyone opted? I will check, I will cross check. Whoever opted artificial intelligence, mathematics students. Only Kiran Raj.
Sir, thanks over, sir.
Huh?
Sir, he has given the link in WhatsApp, sir.
Actually, what I am asking you is, have you opted artificial intelligence? Kiran Raj,
Sir,
have you opted artificial intelligence subject?
yes, sir.
Okay. My dear children, in this maths students, only Kiran Raj opted artificial intelligence. Only that's Kiran Raj only. That subject is opted. Okay, my dear children. Now the time is 3 past 29 minutes. Now you can leave the meeting and watch the video again and write the classwork notes. Actually, Shibu sir told me no math students are there in artificial intelligence. Previously, I asked. Kiran Raj left. Any one of you have artificial intelligence period? Previously,
No.
I asked.
No, sir.
Shibu Damas sir, your class teacher. Sir told no math students opted artificial intelligence, but Kiran Raj told me he's telling that he opted. I will cross check. I will find out whether he opted artificial intelligence or not. Okay. Can I take this period also? Are you ready to listen the class? Can I take this period also, my dear children?
Okay, sir.
Are you? Can I take this class?
Okay,
3:30. Huh?
Okay, sir.
Ken Jackson, Kevin Paul. Preetika, Joseph, Bessina, are you ready to listen the
Sir.
class?
Can you
What,
take
my dear?
extra class tomorrow, sir?
What, my dear Preetika?
Sir, can you take extra class tomorrow, sir?
Tomorrow? At what time? Not now? Not now, Preetika?
Sir, instead of taking extra time now, sir, can you take tomorrow, sir, as a period?
Okay. At what time you have free time tomorrow? At what time?
Sir, even chemistry ma'am said that she's gonna take, so I don't know, sir.
So probably can take it tomorrow afternoon, sir. Like after 2.
Tomorrow afternoon?
Yes, sir. Like 2 o'clock or 3 o'clock.
Okay, 2 o'clock. Fix. Can I fix time? 2 o'clock.
Yes, sir.
Yes, sir.
Okay, sir.
Exam at 10 o'clock tomorrow morning.
Okay, sir.
Okay, sir.
Tomorrow morning, 10 o'clock, maths weekly test 2 on exercise 1.2. And afternoon, 2 o'clock. Let us complete this exercise tomorrow.
Okay,
Okay.
sir.
Okay, sir.
O'clock or 2 to 4 or 2 to 5 also. Okay. Are you ready?
Okay, sir.
Tomorrow, shall we complete that exercise 1.3 also tomorrow? 2 to 4 or 2 to 5 also. It takes time.
Okay, sir.
Preetika?
Okay, sir.
Okay, Preetika?
Yes, sir.
Please. Now you can leave the meeting, my dear children.
Thank
Take
you,
rest.
sir.
Take care of your health. Stay at home.
Thank you, sir.
Thank you, sir.
Thank you. Thank you all.
Thank you, sir.
Thank you, Stains Johnson. Thank you, Stains Johnson. Yes, thank you. All of you watch the video again and again and write the classwork notes.